Hello, everyone. The Hangout is now live. Welcome, everyone, to the Virtual Jug, and a big welcome back, actually, to Mr. Nicolai Parlog. Nicolai, how are you?
Hi, I'm fine. How are you?
Excellent.
Everything okay?
Everything's all good, thank you. And whereabouts are you calling in from today, Nicolai?
Karlsruhe, Germany.
In Germany. And how's the weather there? I hear you said
Yeah,
you
so
blamed me for your bad weather, right?
yeah, so he's the guy with from the UK with the good weather in the background, but I have like rain for like what second, third day in a row now. It's supposed to stay like this until Thursday.
I've literally just come back from Crete, and in Crete everything's bad weather around the world other than Crete, so it's tough to leave Crete.
Can I be obscene on the VJAC or?
Absolutely not. We can imagine what you're saying.
Okay.
Right. So today's session, we've had a couple of, as you know, we've had one session on Java 9, a couple of sessions coming up. And what I wanted from, in fact, we met at, well, not met, but we saw each other again at Javaland over a buffet, didn't we, in Germany?
Yeah.
And, you came up to me and you said, Simon, I'd love to give another session on the VJAG. And I said, well, we're going to be doing some Java 9 sessions. And a session I would love is a practical migration from Java 8 or below class path up to Java 9 modules, or I guess from a non-modular application to modules. Would you say that's reasonable?
That would be a reasonable request, yes. And you got that and more.
So it could be from the Java 9 class path to
no, well, I actually decided to fold the other part in as well. Like just going from 8 to 9 is not trivial either. So we're going to spend a couple, maybe almost half actually, on just working out the trouble of moving to Java 9, and then we're going to modularize what we have.
Right. Okay. Awesome. So let me share my screen. Hopefully you can see my screen. Looks like you can. If I do that, what will happen? Excellent. So you can see my screen, right, Nicolai?
Yeah.
Perfect. So this is to Java Hell and Back, a live migration, as we just mentioned, to the Java 9 module system. And Nicolai is our speaker. You should follow Nicolai on Twitter at nipafx. And yeah, definitely tweet Nicolai any questions that you don't have time for, or that we don't have time for in today's session. Just a quickie that the Virtual Jug is sponsored by Zero Turnaround. And if you are interested in some of the developer productivity tools that Zero Turnaround does, you're welcome to go to zeroturnaround.com and try out both JRebel and XRebel for a free 14-day trial. One additional thing, actually, I'm going to send out this link over the email, over the mailing list tonight. We have a ZT Live session. This is actually a Zero Turnaround session, not a VJUG session. It's actually happening tomorrow. And we've got Venkat Subramaniam and Simon Ritter who's going to be presenting, and they're going to be talking about what's new for developers in Java 9. So if you're interested in what's coming up in Java 9, the bit.ly link there, bit.ly /ZT _ JDK 9. That's actually a case-sensitive ZT part. Do go to that and register. It's entirely free, and it's a 1-hour session tomorrow. Okay, about the Virtual Jug. If you wanted to ask questions directly to Nicolai, you can do that via the IRC channel. If you're on virtualjug.com, you'll see the IRC channel just to the right of the video. Alternatively, you can go to your IRC client of choice, go to the Freenode server, and it's #virtualjug or #virtualjug to connect. Please do share the session and also give us feedback about not just the session, but about the Virtual Jug in general. What speakers do you want? What sessions do you want us to present? Feel free to either ping Virtual Jug or myself directly. So, without further ado, let's talk about Nicolai. So Nicolai, one of the great things about Nicolai actually being well positioned to provide us with a session here is that Nicolai, you're writing a book on Java 9, right? On Java 9 modules, should I say?
Yes, exactly. It's the book is the Java 9 module system. We're publishing it with Manning, and Java 9 has more to offer than just the module system. But surely the module system is the biggest change for various reasons. Because it has a lot to offer, it's a lot of stuff to learn, and it's not the only reason, but the main reason for some compatibility problems. Let's say challenges, migration challenges, which we'll see today a couple of. And so yeah, the book will cover all of that, right? We'll make sure you know everything there's to know about it. know how to migrate your application, know how to modularize your application, know how to start greenfield projects with it, and how it compares to build tools, and maybe even microservices, small part in there. We'll tell you why you could make use of the module system even if you're on microservices.
Okay, awesome. And what I've done is I've posted that link in to the link for your for the Manning book directly in. Can you add to cart? Yeah, you can. You can early purchase that.
Yeah.
So if you're interested in that, feel free to go to that website that I literally just posted in IRC and give Nicolai all your money. Awesome. So Nicolai, over to you, and let's talk about the. Oh, actually, a couple of things I'll say. There's going to be a lot of live coding here. So if on the bottom of your YouTube embedded viewer, there's a little cog there, a little settings cog. Click on that and make sure you're actually getting the best bandwidth there, because that'll help you view. And that's pretty much it. So yeah, please, over to you, Nicolai.
Sure. Thanks. So here we go. Let's see. Let's hide this, and then let's go to the presentation. There we go. So let's go to jar and back. We're starting with an application, a small demo application that I coded up. We'll see later what it does. And we're migrating to Java 9 and then modularizing the whole thing. By now, it would be really good if you know basics of the module system for this talk. So you can make sense of everything that I say. If you don't, I want to give you a small primer to make sure that you have the basic skills down. Before that, a small public service announcement. So Java 9 is scheduled for September 21st, at least as we speak, but I'm sure that will not change anymore. You can see the slides online already. So if you go there, and then on the top right, you will see this talk. And the code that I'm going to present is online as well as at GitHub. So you cannot even code along if you really want to. Okay, great. So about the basics of the module system. First, this is like my condensed motivation slide for why there is even a module system. The jars that we use for, 20 years now have a couple of shortcomings. They have no name that JVM cares about. They cannot express dependencies. Everything that's public in a jar is visible throughout the whole running system, so there's no real way to define an API for a single jar. And there's no concepts of versions. And we kind of got used to that. We built extra tools like Maven, who do all the dependency downloading, and we can have analyzing tools that tell us like which APIs we're using. So we build a lot of tools around that, but it's not really great that jars have all the shortcomings. And we got used to that, but there's still a lot of room for improvement. So in-come modules, after only, 9 years, or almost 9 years. Things are direct opposites of what I just said. Modules have proper names that the JVM and the compiler understand and care about. They make the dependencies on other modules explicit, and they have an API that is well defined, where only the packages mentioned in those, so only certain packages are exported. We'll see how that works in a minute. It still has no concept of versions. So if you hoped for the module system alleviating you of the version conflicts, depending on 2 different versions of Guava and not knowing how to fix that, that's still a problem. And maybe later we can even discuss why, but let's see whether we come to that. Then the important goals of the module system are reliable configuration and store encapsulation. These are 2 major goals. Let's have a look at each very quickly. This is a module descriptor. This is what turns a jar into a module. Every module is just a regular jar, except that it has a module info.class file in there, which is compiled from module info.java, which looks like this. Here's a module that's called Java SQL. It has some dependencies. It requires other modules here. Let's ignore the transitive from mode. It requires these modules. It uses something. We'll see what that means. And then it exports. So these are packages. So that's a module name. That's a package name. Could be a little bit confusing in the beginning, but you get used to it. So the 2 goals that I told you about, the reliable configuration goal means that the module system is aware of dependencies between modules and enforces that all of them are present. There should be no ambiguity. If 2 modules claim that they have the same name, if 2 jars claim they contain the same module, then you get an error. If you have static dependency cycles, meaning A requires B, B requires C, and C requires A, no game, won't work. And you cannot split packages. We'll see later what that means. First goal, reliable configuration. Second goal, strong encapsulation. You will be able to lock in your internals in a way that it's not straightforward to use them from the outside, which is great for framework and library developers. A module like this one can export individual packages. And for someone to use a class, it has to fulfill 3 properties. Before, it only used to be public, right? If it's public, I can use it. Now, the package that contains the class has to be exported, and the module has to read that. The module calling result set in this example has to read Java SQL. So that's strong encapsulation, and everything else will be inaccessible at runtime for the static access as well as reflection access. So this is not about understanding what's going on. It's just about getting an impression of how many modules there are. These are the platform modules, or at least some of them. And you can see, like, it's a small module graph. You can see how different modules depend on other modules. So it's just to give you an impression. The whole JDK was split up into about 30 standardized Java modules and about 70 JDK-specific JDK modules. So they could technically be different on a different JDK. Then a lot of other features in there, which we're likely not going to get into today. So you can decouple implementation and API via services, which is what the users clause that you saw earlier refers to. Dependency and exports can be done finer grained. There are mechanisms in there for reflection and for migration. And the migration ones we'll see later. Great, that's that. Let's start with migrating now. So the first thing you want to do when you move from your Java 8 application to Java 9 is just get it to compile and run on Java 9. So I just told you about the modules, right? And what that's important, so you know what kind of struggles or challenges we're going to face. But you don't have to modularize your application. At first, you just have to get it to compile and run on Java 9. And I think that might even be kind of like the harder challenge, because you cannot really do this stepwise, right? You can't like 80% compile on Java 9. Either it works or it doesn't. So while you can stepwise migrate, you cannot stepwise compile. So this is something that you just have to basically power through and just get your project to compile and run on Java 9. So this is the first part of what we're going to cover now. To do that, to understand what we have, to understand the challenges we're going to look into, you have to understand that there, on one hand, there's the modularized JDK, as I just told you about. There are, of course, still legacy jars. All your applications are supposed to still work on the class path as they do today. And this creates 2 requirements, which are kind of like, look like they're excluding each other. So for the module system to work, everything needs to be a module. But what about your jars? They're not modules in the beginning, right? Right, and they don't have to be. We'll see how. But the other end of the spectrum is that, for compatibility, so I just said that the class path and regular jars keep working. So how does that work together? The solution here is the unnamed module. The unnamed module is kind of like a special case made for migration and compatibility reasons. So the unnamed module contains all the jars that are on the class path. That's even true for modular jars, as we'll see later. But let's focus on just jars on the class path. So your application's on the class path, and all those jars get put together into the unnamed module. They get bundled into the kind of like a big ball of mud that the class path used to be anyway. So what about these 3 properties that the unnamed module, that the other modules have, about name, dependencies, and an API? So the name, as the kind of meta name suggests, the unnamed module has no name. We'll see an effect of that in a minute. But for now, it's important to realize that it's just also there, but you cannot reference it. You cannot depend on it. It reads all other modules that are present. So all code that's in this module can access all other code that's running in the system. So all JDK modules, for example, which kind of makes sense because you wouldn't still be able to load array lists and strings. And it exports all packages. So it's kind of like a free-for-all. But it is still a module in the sense that it has these 3 special properties, but with these 3 special properties, it still adheres to the regular module system mechanisms. Okay, let's keep that in mind. We talked about modules, about their 3 properties: names, dependencies, and APIs, and how the JDK got split into modules, and how your code is going to land in the unnamed module. And with that, let's get started with the application. With that in mind, so we'll see later maybe what the application does, because you can, parts of these things are just mechanical. We got a problem, you can solve it in a mechanical way, so we don't have to really understand the application for most of the steps that we're doing. So we're not going to look at it even. So say you got your application, you're just going to say maven clean install. And just to show you that something happens, I will do this with Java 8 still working. So blah, blah, blah. Look, there's even a test in there. Do you see that? And then I'm going to launch it. So I got the command here that I need for that. This is the one. And now things are happening. And there's another, it actually puts up a small server, and another tab. Let's watch that server. And you can see I pull it every second. I get some XML back. As I said, not too important what it does. You can see it here again. We got some output in the beginning. SLF4J complaints, and then something's happening here. And here you can see every second we get different results back. So the application is doing something. Great. Now let's move to Java 9. So how do you compile with Java 9? Well, you could go into your POM and set it to the Java 9 compiler. But that would mean that the Java process running Maven is still running on Java 8. And that is weird for a variety of reasons and can lead to strange results. I would recommend to run the entire Maven process on Java 9 if you can pull that off. So for example, if you have a Java 9 incompatible Maven plugin, then this approach could be in jeopardy. But let's assume you don't, and this project doesn't. What's the best way to start everything on Java 9? Should set Java home to Java 9, but I'm not going to ruin my entire system. You can have a file in your home folder which is called maven.rc. In maven.rc, you can set Java home just for the Maven process. So this is what I'm going to do now. I went into maven.rc and set Java home to where my JDK 9 is. And then I go Maven version, and you can see here, oh, well, you can see here, that's indeed Java 9 that's running now. Great. So, well, what's next thing to do? We're going to want to compile against Java 9, right? But the regular jar contains something like, oh wait, this is not the one, this is the one. Contains something like this here, where you're setting that you want to compile with Java 8. We could set this to 9, but let's make sure that the Java 8 build still works. You know, we're doing this on the side. Everybody else is coding Java 8, so let's do this on the side. Let's create a profile. So it's not how you create a profile. With this. Files, yes, and then oh, damn it. Profile. And then we have to give it a name. Let's call it Java 9. So what this means, I can define dependencies and build plugins and a lot of stuff like properties just in this profile. And then they're just when this profile, only when the profile is activated, will Maven use those values. I don't want to activate this manually though. So let's see whether I can do something about a typo later. We can activate it automatically. If you do this, then Maven will ask the running Java which version it is. And if it is 9, which it will report because it's Java 9, it will see if this condition is true, and then will activate the entire profile. I'm not entirely sure what I'm talking about. Lookup profiles, they will come in handy when you do a migration. Okay, so now what I want to do is, if I'm running on Java 9, then I want to compile against Java 9. Oh, so sorry. Let's see. Oh yeah, I'm a big fan of copy paste. If you spot errors, point them out. I will make many. So let's say we don't want to use the stupid source and target thing. We know about the new cool release tag. So let's use new release flag. It's new in Java 9. The compiler understands it, and Maven does as well. Okay, so now we're set up to compile with Java 9. Maven will run with Java 9, and when this project gets built, it will detect that it runs on Java 9, and then we'll set the properties, and we'll set release to 9, so we'll compile for Java 9, Java 9 bytecode, Java 9 APIs, everything there is. So let's see what breaks. Most things break, that's how I built the project, but let's see what does. Okay, there we go. Something in utils is wrong. Let's go into monitor utils, and let's see again. clean install. Let's see what we get. Just so we can measure output. There's a compilation failure. It's about the SunMISC base64 encoder in the class utils. Oh, who doesn't love a good utils class? Let's see. Utils. There we go. Oh, look at that. IntelliJ actually got the point of me trying to do something with Java 9 and points out that base64 encoder is gone. So there are two things at play here. The first is SunMISC, all SunMISC, or most, not all, unsafe is an exception. Signal handler are exceptions. But most SunMISC classes are internal API. And as I told you when I talked about store encapsulation, they are gone now. Not gone, of course. They're encapsulated. You can't reach them. There's an asterisk to that, as we'll see later. But the basic concept is easy. If it's an internal API, you can't use it. But there are some other cases in Java 9. For example, some internal APIs were encapsulated. Like base64 encoder, they might just be gone. So they were removed. So this is a case where it got removed. So, but luckily there's a replacement. It's base64. Not that one though. That one either. Let's see. And it's, oh yeah, get encoder. Get encoder from Java util. And then this method is called encode to string. And there you go. So now this looks like it compiles. So I replaced an old outdated internal dependency on old and outdated internal API with its public replacement, which could happen to you quite often. For example, the Nimbus look and feel in Swing. You can use it from some ComSun blah 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 package, but there is a supported version of it. So some of the internal APIs you might be using, which you were fine, nothing happened for years. Now they're encapsulated by default. So if you want to compile on Java 9, they will by default be inaccessible. And if there's replacement, then use the replacement. If there's no replacement and you absolutely have to use that, then we'll go into that in a minute. Let's go on Maven clean install. Let's see what else goes wrong. Wow. So that worked fine. Compilation worked fine, and then tests, and then wait, what's this? Warnings? Why are there warnings? Remember from Java 8? Should we scroll up? It's far away. It's far away. Just trust me. In Java 8, that wasn't there. So what's going on here? An illegal reflective access operation has occurred. Illegal access by ByteBuddy. So ByteBuddy did something it wasn't supposed to. What did it do? That here, it reflectively accessed class loader find loaded class, which is not public method. So now we're going to have a look into what store encapsulation exactly means. Store encapsulation means that everything which is not public in a non-exported package is inaccessible. But on Java 9, for migration, to ease migration, the compiler sees it that strictly. Because when you compile for Java 9, you're supposed to do things right. But when you just take an old legacy application, just want to run it on Java 9, the assumption was made that if applications break, nobody starts using Java 9, nobody can develop against Java 9, that's a whole big mess, so let's not do that. Let's instead give runtime access to internal APIs by default. This is what's going on here. Static access, meaning you have made an import or you use a fully qualified class name. Those access to internal APIs, as long as they're still present, that still works. And you don't even get a warning, you get nothing. Well, you don't get nothing, you get the feature you wanted. So that works. If you use reflective access, you get a warning like this one. So what do you do against the warning? You can get rid of the warning by telling the module system that you really want to use that package. And you can do that with a flag called add_opens, which means you open the package up. You say, look, this package, I really need what's in there. Open it up for reflection. And if you do that, then reflective access is allowed during that run, and you will not get a warning for it. So let's do that next. It's still in the utils project. We go into the POM this time, though. And then first of all, we have to include the same profile again. And profiles are not really inherited, so I even have to include the stupid activation thing, which kind of bugged me for a while. And now I'm going to do something different with this profile. I'm going to tell Surefire that that when it runs, it's supposed to open that package. So let's see, plugins, and then plugin, and then artifact. We use the Surefire plugin. There we go. And then, of course, I don't know all of this by heart. I have a small guide next to me where I just type this thing from. Otherwise, I have to look them up every other minute on the documentation. So this is what we're going to do. This all kerfuffle just means when you run the Maven Surefire plugin, which runs in a separate process, append these command line options to it. And we're going to use add opens. And then we're going to open something from the Java base module. And to be more precise, we're going to open the Java lang package because this is in the Java lang package. Cool. So Java base module, the Java lang package, who are we going to open it to? To everybody. All means all modules, and unnamed means yes, even the unnamed module. So that means code in the class path can now access this specific package as if it were non-encapsulated to begin with.
So would you recommend doing that, and when you add these clauses, to open it to the world, or would, well, I say the world, but everything running in your JVM, or do you think opening it to a certain module would be more in the spirit of modules?
Yes, definitely. Opening to a specific module would be the spirit of modules. But remember, we're not having a specific module for application yet, so we can't. In the beginning, when you just start working, when you just try to get your code working on Java 9, remember, all your code is still running from the class path, so you don't have a module for your own code yet. If you would, then yes, it would be preferable to put in here the specific module that your code lives in.
Okay, another quick question, actually, if I may, from Manny on IRC. Would it be a good idea to preserve the argline property and append to it?
I guess that's what Maven's doing, but I refer to the documentation here. I can't really say.
So maybe it's doing that. Excellent, that's fine. Thank you.
Yeah. So first of all, let's look where this works. Let's maybe install the thing. We set that compiling works and test compiling works. And now look, the warnings are gone. Okay, so let's try to draw some bigger conclusions from this. What I did here using the add opens flag, it's something that I can do specifically at runtime to open packages for reflection so I can get rid of the warning. If I want to access internal APIs at compile time, for example, then I would use add exports. The compiler understands add exports, and so does the runtime as well, the JVM. So the Java C and the Java command both accept add exports. Add opens means open up the entire package from reflection. Add exports means export this specific package, meaning all public types in there are accessible. It is likely that when you have a legacy application, that you will have a few places where you have dependencies on internal APIs that you just cannot get rid of at the moment. If you're really unlucky, those disappear. So that's a situation that I ran into in a migration. So we depended on an internal API that was gone now. Well, that sucked. So guess never depend on internal APIs. Kind of like what you should learn from that. Anyway, if it's still there, then you can use this at compile time and then later at launch time to export that package because you really, really need it. Okay. If you've done that, if you've collected all the exports and opens that you need, I would recommend something else, because then you can do this illegal access is deny. So first of all, let's just see only legal access deny in action. And then you will see that the warning disappears. You get an error instead, because the module system is now instructed to deny illegal accesses. Blah, blah, blah. You will see the problem here. Didn't work, build failure. What I would recommend is collect all the exports and opens clauses that you need, and then set illegal access to deny. That makes sure that whenever a new dependency crops up, you will see it. It cannot happen that accidentally someone in some project starts adding new dependencies on stuff that you actually want to get rid of. So my recommendation is to do this. So this also works. after we've done all that and learned from that how to export packages and how to open packages, there's an even, well, more important thing to learn here. Update your dependencies. Because the cool guys, well, it's just one guy actually, Raphael Winterhalter, who develops ByteBuddy, is like on the cutting edge of the module system. And you don't even need to do any of this kind of letdown, right? In this specific case, all you need to do is update Mockito. Because updated Mockito pulls in updated ByteBuddy, and updated ByteBuddy does the right thing already. So remember, I put all the @opens, I put it away. So this package is still encapsulated, but I don't get a warning anymore because the new version of ByteBuddy doesn't use it anymore. So when you're looking for this exports and opens clause that you put in there, have a look at your dependencies. If they're old, update them. You can even do this pre-Java 9. If you think like we may want to do a Java 9 update in a year from now, you can start preparing now. Update your dependencies, update your tools. Make sure you're ready to jump to Java 9 compatible versions. Good. Okay. So, but this settles the monitor utils thing. So we can go back to, oh, that doesn't work. We can go back to building the whole thing. Let's see what breaks next. Ooh, it's quite a lot. Something in REST. Some project REST, compilation failure. In the package JavaX annotation, the generated annotation wasn't found. Okay, let's go into monitor REST. Let's do it. So let's do this, and then let's go into monitor REST here. And where was the trouble? On statistics entity, whatever that is, we don't mind. Generated, yeah. Why would that not be available? I mean, heck, it's an official thing. Why would that be gone? Or why would they not be there? Well, let me tell you a story about Java EE modules. So we talked about internal APIs. Let's not talk about Java EE modules because they're not included by default, which may seem very weird and which leads to a lot of manual add modules things, but there's a good reason for that. One reason is the split package problem we're going to look at next. But the point is that typical Java SE API is just in the JDK, right? Nobody is bringing their own Java lang, or almost nobody's bringing their own Java lang to the plate. Everybody's just using the one that's in the JDK. But the same is not true for these Java EE modules. There are application servers which contain code, or there are endorsed standards which have more updated versions of the same packages. So there's actually a lot of code out there that says, look, I'm the I forgot the list of modules, the list of packages here, but they say like, look, I'm in the JavaX annotation package. And to not create this conflict between two artifacts having the same packages, they're by default excluded. So if you want to have them, you have to add them manually. So let's do that. Let's go back and copy some code. I told you I'd do that. Here you go. Oh, wow, that worked like a charm. And then we don't want to have the Surefire plugin, though. We want to use the compiler plugin. And I want to tell the compiler plugin that it needs to add this module, which contains the generated annotation. So, infuriatingly, this is not the same syntax. So now it's called compiler args. Don't ask me. I hope I'm using the most up-to-date of these, by the way. There are a bunch of different ways to do this, and if you spot an error and say, this is not the way to add compiler arguments, you might be totally right. Do it the way you think it should be done. So I'm going to add the module. It doesn't say which one that is. Under other different circumstances, it would. But if you trust me, it doesn't for the moment. So let me add that manually. Wait a moment. Here. Java XML. Oh, I'm already here. Maven. There you go. Invalid flag, add modules Java XML bind. Boy, did this take me long to figure out. The Maven plugin splits the argument here. So it gives you one argument looks like this and another which looks like this. And then the compiler bars and says that's not right. So what you actually have to do is something like this. So you have to close the argument, add a new one. This is weird. As I said, it took me a while to figure that out. So now it should work. Oh, for crying out loud. What did I do wrong now? That's not fair. The first mistake was on purpose. The second was not. Oh, yeah, sorry, it's add modules. Here you go. Generated is still there. Let's see what else we skipped then. Where are the other arrows gone? So first of all, the generated annotation from the JavaX annotation package. Oh yeah, that was my problem. Oh, my mistake. Wait. See, now I blindsided myself. Let's have a look at this. Okay, right. So we have this problem for more than one annotation actually. So we used generated in there, but we also used other applications. Other annotations. And these ones of my annotation. Wait a moment. See, that's the problem with live coding. Let's see whether we can brute force this problem. Okay, look. I'm going to jump ahead to the next problem because I think this is related. It's not how it's supposed to turn out, and I'm a little bit confused that it does. But let's ignore that for a moment.
Actually, if you go back to the POM,
yeah.
Did you put Java? Oh no, sorry, I think you said JavaX. It was Java.
Yeah, but all the modules start with Java, so there are no modules like this.
Okay. I thought you had JavaX, but that's cool.
No. Okay, so let's do the next problem because I hit another problem in there, which is maybe the most nefarious one that you can encounter, and I think it's tripping me up here as well. So the reason why the Java E modules are not in there in the first place, or one of the reasons, is what I said is a split package problem. So let's talk about that. The specification says that no module should read the same package from two different modules, but the implementation is much stricter. The implementation at the moment disallows two modules to contain the same package, whether it's exported or not. So you cannot have two modules which have, let's just pick a random example, the JavaX annotation package. So for named modules, this is checked. If you have the JavaX annotation package from the Java XML bind module, and you have a different named module, it's a proper module with your module info in there, then when the module system puts together the application, it checks for this split package situation, and you get a warning or even error. I'm not sure right now. I think you get an error. Anyway, so you will be aware of the situation. But the unnamed module is not checked like this for compatibility reasons. If it were, if the unnamed module were exposed to all the different checks that other modules are exposed to, then this would actually mean that much fewer application would work on Java 9 than it would work this way. So the unnamed module is not checked at all. This sounds fine, but the problem is, and this is kind of the kicker, whenever a class is loaded from a package which exists in a named module, the class loader will know, hey, I know that package. It's in that module over there. It will go to the module over there and say, load this class. And then the class loader will realize, wait, that module doesn't contain that class. So the class could be on the class path. The class could be in the unnamed module. but you'll never see it. So this kind of sucks. So if you have a class in a JDK module, sorry, in a JDK package, but on the class path, you will not be able to see it during compiler runtime.
I think I might be able to fix this problem. Do you actually need to use 2 arguments, or is it add modules equals then module name?
No, it's this. It's without equals.
Are you 100%? Go on, try it with an equals. I bet it.
I'm 100% sure, but we can try.
On. I'll write a book about it if it's right.
This works. You gotta have to, because I'm quitting. What's weird is that I actually don't get a different error. Cannot find symbol. I would expect. Am I in the wrong POM or something? Something's weird here. Wait a moment. I think I'm doing something fundamentally wrong. No, okay, that worked. But let's go back to the split package problem, because I think it might be related. So when you have a split package, and you can check that with jdeps, the jdeps tool, if you have a split package, you can be in 2 different possible scenarios. Have something which is supposed to replace an entire module. You might have, this might be a module that contains an endorsed standard, and you might have the updated version of that standard. You want to replace the entire module. Then you can use the upgrade module path and with this way, you tell the JVM, like, look, over there, you will find some modules, use them to replace the modules that you yourself contain. It's kind of like the proper case, so to speak, the case where a split package is kind of okay, and this is the way to resolve it. You just leave out the JDK module. Hence, the split goes away, because now you have this package only once. But if you're in a different situation, if you have only individual classes, then you kind of need to merge the jar into the module, which is really weird. And the patch module option says only do this for tests and don't use it in production, and blah, blah, blah. And you should heed that warning. But with that said, look what we use here. We use the JSR thingies. And if you look into JSR, that didn't work out. Still don't work out. Great. So if you look into JSR 3 or 5, you will see the not null annotations. For example, this one. This is in a jar, and it lives still in a JAVAX annotation package. So with this thing, like this, the JSR 3 or 5, if you use that to check your code for nulls, then it kind of like they have no choice. You're forced to use something that comes from the JAVAX annotation module. And if you use the module containing those annotations, then they clash. Then you have the split package. So what you're going to do then? Then you're going to have to patch the thing. And with that, patching means, I can talk you through it while I type it. Patch module means you have this module here, right? You have this. I think I know what I did wrong there. Let's continue this though. We should still. You say, look, you have the Java XML. I think that's a problem with that. That's my problem, I'm sure. See, it was the. There are 2. That's evil. There are 2 missing modules here. Now, come on. Yay. See? Haha, okay. Split package. Put it on hold. I'll come back to it in a second, I promise. I added the 1 module, so some of the compile errors went away. I added the other module. So there are 2 modules, right, that I added. And the other part went away. So now I'm seeing the generated annotation. I don't get the problem with the generated annotation anymore. Now I get the problem with the non-null annotation. So to recap, I used annotations from 2 different Java EE modules. As soon as I add them both, I get the split package problem, because now the Java XML WS annotation module and the JSR 3 or 5 jar, they split a package. And now suddenly the non-null annotation is gone. It's invisible. It's in there. It's in the class path, but it's invisible because whenever I load something from JAVAX annotation, the compiler or the runtime will go off to the module that contains it and asks it for it, and it doesn't contain non-null. So there you go. Okay, let's fix that. Whew. Now let's patch this module, because that's what we're going to do. We're going to say, I know there is this module, but it's not good enough for me. I need more in there. So I'm going to patch some stuff in there. And this is, as I said, it's not only shady, it's also not that clear how to do that properly. This is maybe the best way I found that you can actually commit. So you go to your local repository, and then you kind of locate in your local repository, was it? Google code findbug /JSR, /JSR 305. And then, you got to know the version, which sucks because the version is not even in here. And if you update the version, you have to change this as well. So this is really not the best way to make your build reliable, but it might just be the way you have to do it now. And if you have other split packages, you really should try to avoid them. But if you absolutely have to have them, then you have to do this. I'm talking about package splits between the JDK and your jars. Splits between jars and the class path are still fine. So if you split a package with, let's say, some Spring module, some Spring jar, then as long as that is not a module, that's no problem for you. Okay, so now take the content from this jar and put it into the Java XML WS annotation module. Now let's see, what do we get? We get that patching modules is not allowed with release. Why? Actually, I didn't hunt that reason down yet. It's just not allowed. So remember that we said we used a new fancy release flag here? Yeah, that was a mistake. Again, one thing that you learn while you do this, you know what sorry, that was correct. So the things that I'm walking you through in half an hour now, obviously took me a little while longer to get, but nothing of this it looks a little bit chaotic, but every learning experience is, right? So most of these things kind of make sense when you know more details. This particular thing doesn't make sense to me yet. Let's see where that changes at some point in the future. Okay, so we can build that. That looks good. Now let's go back to building the whole project. Test. Oh, by the way, there's a single test here. Nice, huh? It failed, of course. I know a guy who said, like, why don't you just delete the test? Good. So we built the whole thing. Everything works. Now let's try to launch it. Earlier, I've used this command. When I'm building the main project, I'm copying, this is what you see here, I'm copying all the dependencies in libs. That makes it a little bit easier for me to type the command, and we're going to need them later. So I'm saying, look, in the libs folder, you'll find all the dependencies. And this is the main jar. You're also going to need that. And then launch the application monitor.main. Now, all I'm going to do, sorry.
So this is a good point, actually, to ask a question from Manny about, so Manny's actually not so much a question, but a request. Can we run jdeps on the build app to see what it says? And I guess a question that I'll ask is, would jdeps have worked out which modules your application depends on, so that we could maybe work out that java.xml.annotation? Would that have fixed that? Would that have worked out what we needed to add?
We'll use jdeps later for kind of like different use case, but we can look into that then as well. So I think we're going to link that later anyway. I wrote a whole blog post just the other day about migration, and then when you hunt down, especially when you hunt down internal APIs, it's really useful to use jdeps. So I can definitely recommend to run it. We'll see later how to do it. But yes, in this case, the internal APIs it would discover, and it would also be able to tell you which class the annotations that are just used came from. Sorry, which module they came from.
Right.
Okay, so when I do this, I get an error because now I'm trying to run with Java 8, and Java 8, of course, doesn't speak Java 9 yet. So what I do, I can only recommend this. I symlink Java 9 and Java C9 and what else? I don't know. More. There are jar 9, of course, to the nine versions of this. So you can see here. Can somebody remember whether it's -v or -version? So see, Java 9 is indeed Java version 9. So now let's get back to this command. So I'm using the same exact command, and oops, that didn't work. So obviously it tried to launch it, but then it says something like I get a class cast exception in my main method. What the hell is this? So let's look this up. What the hell is this? So in my main class here, it says at 46. This is here. Yeah. So what apparently happened here, if we scroll up far enough, you could have seen that earlier. In the beginning, there was some output. The application said, "Look, this is all the content of the class path," which kind of might make sense, might not. Who knows? And this was a good way to do this in Java 9. You asked your class to give you the class loader. And because you know it's a URL class loader, you just cast it because you need this method here, get URLs, which is only there on the URL class loader. There are other use cases for why you might need specifically the URL class loader. So this is a not uncommon practice that you can see in code bases. Yeah, this is not going to work anymore because the class loader you get back now is still like before. You get back a class loader. So the same super type, of course. So the API did technically not change. Well, the API did not change at all. That's true. But internally, you get back a different type. So this kind of thing is a great example of where basically the entire ecosystem can depend on implementation details. Because some tools do it like this, and we got used that that's always URL class loader, but that was never specified. And it would not be fair to blame Java 9 for breaking this because you shouldn't have done this in the first place. I know sometimes it's the only way to fix to implement a feature, but still, I think we should face the music and be aware of that. Us depending on things like this, it's basically our fault if it breaks. So what happens here is that you get different class loader back. Specifically, you get the app class loader class, and this is also not public. The only public super type is not class loader, but there's even a lower class. I think secure class loader or something. Okay. Let's not look at that now. Or let's. What the hell? Now I get it. So class loader, and then there is the secure class loader, which is also public, and you can cast it to secure class loader if you want to. We're still depending on implementation detail in the sense that you don't know it's secure class loader, but at least it's still of that public type. Trying to cast it into this type would then mean you have to, access the internals of this module, which you don't want to do. So you can't use the URL class. You can't rely on the fact that it's a URL class loader anymore. How do you implement this feature? I gotta tell you, I don't know, because while there are a couple of new methods on class loader, I don't think I found an equivalent for this one. But it depends on individual use case. If you have a cast URL class loader, look at the use case, look at the methods on class loader. If you can fulfill it any other way, do that. If you can't, it kind of looks like you have to let this go. So I don't look into this too long. I didn't look into this too long, but I didn't find a fix within a couple of minutes. So I decided not to fix it, but say that we're no longer going to support that feature. So building the whole project again. This is ridiculous. There's like one class or two classes in each of the projects. So then do this again. And we didn't find the Java XML bind exception, blah. So this again is the same reason that we had earlier. This is in the Java XML bind module, and the Java XML bind module is not available by default. So we add this thing. Java XML.bind. Sorry, this is the name of the module without the X. And now we get something. And let's look at the poll. Yes, indeed, we get stuff back. So another thing to take away from this, if you have add opens or add exports flags in your build script or in your build tool, then chances are high that you will also have to apply them to whatever launch script you use. In this case, we used to have the add opens in there, but that was only for testing. So that, of course, doesn't apply here. And then also the other package that we had, so the other module that we added for the other annotation, we don't have to add this here because it's runtime retention. Sorry, it's compile time retention. So the annotation is not even there at runtime anymore. But by and large, these are kind of like exceptions. By and large, if you export something at compile time, you might want to export it as well at runtime. And as I said, if you don't have to do this, because by default, Java 9 will allow you to, at runtime, use internal APIs. But if you do that, you can then deny these illegal accesses and make sure that you are aware of new problems creeping up, not only in your code, but also in your dependencies. Because you're only compiling your own code, right? But your dependencies might also make trouble, and you want to know what exactly that is they're doing. So we did this. We fixed the splitting package. And with this, we're done with our migration. I alluded to the post I wrote. There are a few other things that can go wrong. The version scheme in Java is new. So not only does this give a better version back, it's also not. This is the old version, and now this is the new version. Oh, great, that didn't work out. Didn't this give a longer one? Oh, there we go. So you get more back now. You used to get back 1 dot something, now you get 9 dot something. So this is another thing that changed. Also within the JDK, if you ask for Java dot version, you also get something that starts with a 9. So maybe code breaks because of that. There used to be an option, the X boot class path thing, that is gone, for example. These are more minor things. I think the bigger issue are internal APIs, Java EE modules that you have to add, and then fixing split packages. Split packages are not really that often, but if you see that, then you might have a real problem on your hands. You'll find out. Great. So I would say let's have some questions about running on Java 9, if there are any, and otherwise we start modularizing our application.
Okay, so mostly I've actually been asking the questions as we go, so we can now continue, I guess.
Okay, so to make sure if I screw everything up, I can have a fresh start. Actually, create a small branch here, which contains all the fixes we just did. So this is the version again that. Sorry. This is the version that basically what we just did with the migration we just did, and we're now going to start modularizing the code base. So regarding that, let's start with the 2 paths. So all this time I've been only talking about class path, right? Because we don't have modules yet, so you wouldn't use the module path. Because the assumption kind of is like the class path is for regular jars and the module path is for modular jars. But that's the wrong way to look at it. You should look at it in the way that the class path is for things you want in the unnamed module, and the module path is for things you want to have as named modules. So we're now going to start using the module path. And we can't, unfortunately, use Maven for that anymore, because as it stands, Maven has a small bug that keeps it from properly using the Java 9 module-related features. Otherwise, it's all set up. It basically does what we'll do in a minute manually, but it doesn't do yet. You can't use it yet. So I wrote a small compile script, which does basically kind of similar things. We can have a look at it here. Things are happening. There's a compile script here. Just a lot of copy paste and changing small things. We create a build folder. These are all the dependencies that we have. We push all these dependencies into this class path folder. Then we have a module path folder. And the idea is all the individual compilation steps that we're going to go through here are going to put what's in here on the class path, are going to put what's in here into the module path, which is, as you can see, is now empty. And this is where it will compile the class files, and then we'll package them into modules here, or jars here. As it stands, they're only jars. So basically what each step does is it builds a single project into one of these classes folders, then it creates a jar from it, and then it copies the jar into the class path thing, so you can see our own application, our own artifacts in here as well, so that they're available for the next step, because the next step will again put this into the class path and this into the module path, do the next compilation, so on and so forth. And then if everything works, we can run it with a script. It's also helpful because we're going to add a few command line flags there as well in a minute. Okay. So now let's do the jdeps thing, because jdeps really help us see how our system is, how our application is structured. And of course, we could have done this as well before the first migration. There's no really reason to do it afterwards. You can do whatever. jdeps is a great tool for this. Also wrote an article about jdeps, to make more, make more ad for talk you into reading more of my stuff. But for now, I'm not going to explain it in depth because that would take a while. Let's instead just use it. I'm using jdeps. I'm trying to create a summary to recursively go through all my dependencies, which I specify on the class path here. And then please use the file that was created in here. Okay, so we get something. So what do we get? First of all, it actually realized that there's a split package. Damn, should have used it earlier. It says, look, in the Java runtime, there's this module, and on your class path, you have this module, and you get a split package, namely this one. Should have done that before. Then we got a lot of dependencies here. Apparently, we're using a lot of Jetty server things and other Spark and WebSocket servers. So not all of that interests us. So what I'm going to do is I'm going to make sure we only see what we actually care about. So I'm going to limit it with include. You can say only include dependencies because it actually checks for classes. In this way, it just aggregates the results to jar levels, but it looks at individual class dependencies. And now I'm only going to look, please only look at something's own classes whose fully qualified class, and I match this regular expression. Run that. And now we get, these are all our modules, or sorry, not that modules, only our artifacts. And they depend on stuff. You can see that main depends on a lot of our own artifacts, but also depends on Java base. And then here we can see Java XML bind. We can see not found. This not found is the non-null annotations. Because remember, jdeps, like the rest of the Java 9 tools, sees the package, looks into the proper module, and then skips looking at the class path. So this hidden behind this is the generated annotation that we didn't find. Good. We can actually turn this to a diagram. You can use, I use the dot thing. I will go explain that even less. Just believe me, this is what we want to do. No, this is not what we don't do. Why not? Oh yeah, sure. Because we didn't create dot output yet. So we're going to do that as well. Just going to tell jdeps to create dot output. And now this should work. Great. And now to open it, we get this. This, I hope everybody can see that. So we can clean up a little bit. You will, at the bottom, you will see a module where everybody depends on. This is Java base. It contains things like object and string, and everybody needs it. So there's not really a way around it. So we can just kick it out of our script, because if you look at the file that jdeps created, just a blank text file. That's the dot format, so just blank text. So we can use some typical command line tricks to kick some things out. The first thing, I want to kick Java base out. All Java base dependencies, they're just noise. I want to kick them out. And another thing is, I want to remove the whole snapshot thingies, because that's also just noise. And then let's create a new PNG, and then let's have a look at it. This is better. So now I removed all the minus snapshot.jar stuff here, because that was just noise, and removed Java base from the bottom. And now we can actually see something. What we can see here is that our main module depends on some observers, whatever those are, some statistics, persistence, and then there's the REST thing. We have our utils here, and these are our external dependencies. And as we can see, only REST really has meaningful external dependencies. Everything else is just Java base. So there are two ways to migrate now. We look at this and we can say, what can we do? And the easiest approach is to start at the bottom. If you now change your perspective a little bit and assume you're a library developer and you have few or maybe even no dependencies at all, then you're basically also in a global dependency chart at the bottom of this. So bottom-up migration means we start at the bottom and we're going to just modularize something individual, which is down there. So let's do that, or we can go over here. Let's start with utils, actually. So now we're going to create our first module. We're going to create the utils module. So let's go there. Here's utils. If IntelliJ knows that you're on Java 9, it will actually let you create a module info Java file. Oh, yeah. OK, let's add this to Git for now. Let's call this monitor.utils. So this is the name. Then what else can we have? We can have requires clauses, but it requires nothing. Everybody uses Java base, so you don't actually have to require Java base. We don't use anything else, so we want to export, but we want to export something, namely this package. I said earlier that this is a package and this is a module. And for a while there was, I think I actually made this suggestion as well. Why not have module names like this, maybe? So it's easier to distinguish modules from package names. But both have a dot. You have to know where goes which. The interesting advantage of this is usually you will have your packages that your module contains will usually be prefixed by the module name. So it's unlikely that you will have a package like this as well. Remember, like for most packages, we use the reversed DNS naming scheme, and we should also use this for modules. So in the end, you get that most module names will be a prefix of the packages that the module contains. Not mandatory, though. Just, I would say, it's good practice. Unless you have a reason to not do it, I would say do that. OK, so now we have a module here. What do we have to change during compilation? Not that much, because I use this thing, which just enumerates all the .java files in this folder here, including the module info Java, and the compiler just knows, oh, there's a module info Java file in there, so apparently I'm compiling a module. So let's just see how that fares. How we fare with that. That's not good. Let me. You're not supposed to see this, I don't mind. But oh, sorry, I need. OK. What? OK, whatever. I'm doing something very obvious, very wrong. I don't know what it is, though. So anyway, I was just trying to open this in a different image viewer. Never mind. Let's go back here. What we're going to do now is we're just going to compile this. So it looks like it does the same thing. Remember, we just said create a module. We didn't do anything else. We didn't put it into a module path or anything. We're just using it exactly like we used it before. And lo and behold, it still works. That's important if you want to try bottom-up migrations. Because you can put modular jars on the class path, just like you could before, and everything still just works. So if you have a library, you can modularize your own project, and your clients don't have to react to that. The users don't have to do anything differently. If they take your module and put it into the class path, it just gets rolled into the unnamed module just like before, and nothing else happens. So this way you can start bottom-up migrations. Let's do a little bit more of those. We'll just start with utils. Let's put this onto the module path to get used to that, because it will also give us the chance to fiddle with any other command line, or with the command line flags we already know. So now we want to use it, put it onto the module path. So remember, in this build folder here that I showed you earlier, we're just going to copy the whole thing into the module path folder. So after the next compilation, it will end up here, not here. First of all, that surely breaks some things, right? Because whatever depends on utils won't find it now. I hope. There we go. Okay. So all the other projects don't depend on utils, but REST does, and REST doesn't find it anymore because now it's in here and no longer in here. But that's weird, right? Didn't I say that when I compile REST, that I say, look, I use the compiler, I say the class path is in this folder, the module path is in this folder, so why doesn't it get picked up? The reason for that is the exact same reason that I use, why I have to use add modules here. Not the exact same reason, but a similar reason. The module is not available at runtime. It doesn't make it into the module graph, into the set of modules that are visible at runtime. The reason for that is that whereas with the class path, every jar on the class path was available during class loading, the idea with modules is that you can use a directory as a module path and say, look into this directory, but only the modules that somebody needs in there are actually going to be used at runtime. So if any module declares a dependency on another module and another module, then all those dependencies are gathered up, and exactly those modules will be available at runtime. The other ones won't be. So the problem we have here is that our monitor.utils module is not dependent upon in the module system way by anybody. Nobody says requires monitor.utils. So if you want to put it onto the module path for whatever reason, maybe because it takes a lot of dependencies, you want to run those on the module path as well, then at some point we have to add these to the module path manually. So let's have a look at this thing again. Basically, we're on the right here, and all the dependencies down there, they could all be modules, and they could all be pulled on the module graph. They could all be pulled from the module graph. Everything would be fine. Sorry, from the module path, and everything would be fine. But these arrows on these dependencies on utils, the module system doesn't know about them because these are not modules, REST and main. So what we do, we manually add the module. So when you're migrating and you start having your own modules, then you might be required to do this. Maven does this out of the box. So it puts modules where they belong. Sorry, no, Maven does not do this out of the box. It puts modules where they belong, so it would end up on the class path in this case. If you want to use the module path, we have to do it manually. So let's go and say monitor.utils here. Not the only place, because when we build monitor, I know by heart that it also uses this. So we want to add it here as well. So now compile should work. There we go. Now run won't work for the same reason. Bam. Not found monitor utils. Same reason. We gotta add that module. Oh look, we're already adding some modules. Let's just put it back there. So you can have several add module clauses or just one and then enumerating all of them, whatever suits your needs best. Okay, so here we go. This is up again, and here the poll of every second works as well. So this looks fine. That was monitor utils. And now we're going to go through the same for a couple of modules just to get used to it. We're gonna have module info here. We're going to call it monitor observer. Remember from the chart, it's also at the bottom. It requires nothing. So only exports the package, in this case, again, of the same name. And let's do that. This is kind of like an API. The observer is kind of an API, and alpha and beta both they both implement that feature, so they both need to see that package. So now we actually get our first requires clauses because they require monitor.observer, and they export the same. Weird, no code completion, huh? Okay, that's that. And then here we go. More with the copy paste. Oh. Now these three are modules, and as I said earlier, we can just keep using them on the class path. But for the sake of going through this exercise, let's put them onto the module path. So first of all, we're going to copy them in our module path folder here. This is observer, and this is alpha. Copy to the module path. This is beta. Copy to the module path. So now these three modules, alongside utils, will end up in the module path on the next build. So where are we using that module? That's actually quite a lot of places. So we're going to have to add that to the different modules. Persistence, I think actually this is an exception. Statistics does. So say my notes, where is it? There we go. Does. It would be nice if it wouldn't be nice in general when the API would depend on the API module would depend on the implementation modules. Actually, that would be horrible. But in this case, it would be nice if observer would pull in these other two, because then we wouldn't need to depend on alpha and beta. Speaking of which, shouldn't it be enough to just depend on alpha and beta? And we'll see it does, because what I said earlier, right? Alpha and beta depend on the observer API. So as soon as I add one of them, observer gets pulled in as well. So let's try that. Let's see whether I'm right here. So my notes say REST doesn't use that package. That sounds weird, but let's give it a try anyway. Let's see what happens. Okay, this is good. This is not good. Oh, I guess. Okay, this error just means I forgot a backslash somewhere. When building statistics, see, got a backslash here to continue the line. These would be huge ass lines if you just put them into one. So I split them at the proper places, but then you have to remember this thing. Oh, wow. I didn't suspect that it would go so smoothly. Running doesn't work because, I can't see this. So I have to do the same thing here. Or I just pull in these two. So note that I never explicitly add monitor observer. As I hoped it would, have adding alpha and beta suffices to pull in their dependency. Okay, so this means we have beta, alpha, and observer modularized. We have utils modularized. And let's look at a different case now. Let's do something where we modularize REST. Don't go totally insane. It would help us to also modularize statistics, though. So let's quickly do that as well. Let's say I want a new module info in our statistics module. Where we go? Wait, what? Oh, there it is. If you have real applications, then most likely you're not only exporting one package, and maybe you have more dependencies here as well. You can use jdeps to create kind of like a raw version of your module descriptor. It doesn't work very well with this specific layout, the typical Maven layout that I have here, so I didn't use it for this exercise. But you can create, especially the requires clauses are kind of valuable because you don't have to go through the POM manually and like look at them. So that's neat to get you started. So now the statistics module also has to go into the module path. This really isn't right. Doesn't belong here. So it doesn't belong here. But say that because statistics doesn't depend on alpha and beta. I have no clue why I would make those notes. Further, we would have needed this, but now we don't need it anymore. Would have needed just monitor observer, but we don't, because now statistics can express that itself. Can express itself that it needs monitor observer. So we don't have to add that explicitly anymore. Who uses statistics though? That's happening in places. So here's the persistence module, which seems to use statistics. And then so does rest. And finally, so does the main module.
I think you spelled statistics wrong then.
Every single time. Damn copy paste. Statistics, that's better. So while this compiles, let's update. Thanks, by the way. That would have taken a moment. Okay, so that works. Let's see. Yep, polling works as well. So that's fine. So now statistics is modularized as well. Now let's go to the original use case. Why I started to even have statistics in there, because now I want to modularize rest. That is a totally different case, because earlier I started from the bottom up, observer, then alpha and beta implementations. Before that, the utils. None of them have dependencies that are unmodularized. That might be the case if you're writing a library, a small one, or if you're writing library with very up-to-date dependencies. But if you're writing an application, especially a large one, then you would have to wait quite a while before all of your dependencies are modularized, maybe even forever. Who knows? And if you want to still use the module system for its various features, then you kind of have to modularize. You have to be able to modularize your application, even though your dependencies are not yet. And this is what we're going to do for REST, because note that none of these, well, Java XML bind, of course, but neither the Jackson nor the Spark dependencies are modularized. These are just regular jars. So what can we do? We can go back to the realization that what I said earlier, everything that goes into the module path is a named module. Specifically, jars get turned into automatic modules. If you put a normal module on the module path, it's just a module. If you put a jar without a module descriptor on the module path, you're informing the module system that I want this to be a module. And the module system goes there and it's like, okay, it doesn't have any information, so I'm just going to make it up. So it needs three things, right? The name, dependencies, and exports. So the name is built from the file name, or if it has one, from a manifest entry. And this was a great change over the last months that should really make migration easier, because that means that all the libraries, all the frameworks out there, JUnit 5 already does that, can choose the module name now, but they don't have to define modules yet. They don't have to settle on their specific module structure. They don't have to compile against Java 9. They can just put this into the manifest entry and say, look, if you use me as an automatic module, this is my name. Please call me spark.core, for example. And then later, when they build proper modules, then they can call their module spark.core, and they don't have any module name changes, because that can cause trouble. So the automatic module gets either this entry as a name, or if it doesn't have one, and our jars don't have one, it uses the file name to guess a module name. The automatic module can read all modules, including the unnamed module. Again, this is a big deal. The dependencies that we have are far more than these. Jackson and specifically Spark depends on Jetty and other stuff. So the dependencies below Spark and below Jackson are deep. And we want to leave them on the class path. We could pull them onto the module path, but then turn them all into automatic modules. But that would have their own set of problems. We're not going to discuss those. But in general, the default approach should be, I look at my immediate dependencies. I pull those onto the module paths into automatic modules, and everything else stays on the class path for another while. So The automatic modules, though, can read the unnamed module. Remember, REST cannot read the unnamed. REST cannot read the unnamed module once it gets modularized, but automatic modules can. So they're kind of like the bridge. They're a bridge from the named modules to the class path. And also, automatic modules export all packages because there's no reasonable way to find to determine the API. So, with that being said, let's get going and let's create a module descriptor for REST. Monitor REST. There we go.
And while you're doing that, can a named module have a dependency on an automatic module?
Yes. Oh yeah, sorry. I should have said that. That's actually kind of the whole point. Yes, I should have led with that. It absolutely can. This is the point of an automatic module, to be able to kind of bridge to the class path, but by pulling individual jars onto the module path. Where there are suspect to the whole, to some of the checks, for example, the split package check. So first of all,
that's an interesting way of looking at it, actually, that an automatic module is a bridge to the class path. I always looked at an automatic module as something whereby if you wanted to move a big app across, you'd move it to the automatic module, turn it into an automatic module first, or if there's a library that you want to use that isn't a named module, but you don't want to turn it into a named module, you could just drop it into the automatic module, turn it into an automatic module, and then use it from the named module.
Yeah, you can definitely do that. So you have this use case that I have something that is not a module. How do I depend on it?
Yeah.
And there's just the one way to turn it into automatic module, and then so you get that, you get what you described. And the other advantage is that it can depend on it can automatically read on everything that's on the class path. So this part so far is standard. We use these, by the way, these are deprecated, interestingly enough, but I didn't find out what their replacements are going to be. We had to have this add modules thing, right? In the compile, we compiled monitor REST. We had to say add modules, these two. Yep, that's gone now, because now monitor REST turns into a proper module and can express its dependencies. Also on utils and statistics. So we can get rid of those two, utils and statistics. Great. So if you will always have some noise, some command line noise on the border between unmodularized and modularized modules within your system. I mean, of course, if you can do all the modules at once, then that's fine. But if you have like a couple dozen or 100, and you might not be able to, you can modularize them from the bottom up or from the top down. But every border that you get, you will have some noise with all the command line flags that you need to make it work. So it makes sense to kind of like choose maybe one coherent set of jars and start modularizing there, and then move to the next, and not go and just basically randomly picking modules. So if you can do that, bottom up would be my recommendation. Now, where was I? Yeah, right. I wanted to require more modules here. So I want to require these other dependencies. Spark core. Have a look at what the file looks like. It's spark-core, and we get turned to spark.core. You can try that. There's a way to find that out, but it's actually that hard to guess. Letters stay letters, numbers stay numbers, everything else gets turned to a dot, more or less. Jackson core, Jackson data bind. And this also exports something, namely monitor REST. Right, so now where are we? In the compilation, we now create the monitor REST module. So we also, when it's done, want to copy it into the module path. But remember, if we go like this, if we say compile with these three module dependencies, then these things have to be on the module path, right? So the three things, Jackson core, Jackson data bind, and Spark core that we just declared as dependencies, now they also have to be on the module path. So let's do that. Let's move Spark, sorry. Let's move. Sorry, I thought I once got the build. Class path. Yeah, remember it's in two places here, right? This is like kind of like the eternal deps folder, which never gets touched, and all of this gets rebuilt every single build. So that's kind of duplicated. So I want to copy it from the class path to the Spark core. I use a star here, so this is not version dependent. Although I hope that if you have to do this during a Maven or Gradle build, for example, you would get some tool support there. So we want to use this, and then also Jackson core. Oh, no, that's wrong. And Jackson data bind. So I think that should be it. I declared the 3 dependencies. I declared the 3 dependencies here. And so before I compile this module, I copy them onto the module path folder, which, as you remember, surely is used on the module path. That meant I could get rid of the add modules thing, not the patch, of course, because that's just still a problem that was there before and still remains. And now here we'll also have to add monitor.rest, which kind of like makes it really useless. We should definitely modularize main next. Let's see how that works out first. Oh, let's go to the run thing and fix this as well. Monitor.rest also has to be added manually. Oh, just 2 warnings because they have been deprecated. As I said, I'm curious to find out what the replacements are, but there you go. Oh, now I remember. There was some of the Java EE modules were supposed to move someplace else so they don't kind of like mess up the Java SE module space. I'm not sure. Anyway, it compiled. And yay, it's running. So here we get stuff. But look at this. Here we get that, oh, not anymore. So let's run this again. Here we get an error message back. The reason why we get an error message back here is because I did stellar programming. Like I'm sure all your colleagues would be proud of you if you do exactly that. Somewhere around here, I'm doing some marshalling, and if anything goes wrong, I just return the whole exception string, which then gets used as the answer. That's why I see it here on the curl. So basically, I give the error message back to the user, which I think is best practice I heard somewhere. So what we saw here, though, was that now that REST encapsulates its internals, the JAX-B can no longer, damn it, go quick. Let's just curl once. Look at this for a moment. Okay, so the monitor REST with this JAX-B class is defined in a module, but it must be open to this module. So the Java XML bind module wants to reflectively access our module, but it can't. Remember, strong encapsulation. Monitor REST strongly encapsulates the statistics entity. So the Java XML bind module is not able to access it. Remember earlier I said reflective access is okay by default on Java 9. That's true, but only from the class path. This is a pure migration, pure compatibility design. It's only meant that code on the class path can do all the illegal stuff that it did earlier. But code in the modules is not supposed to do that. So illegal access from module to module is still not allowed. So what do we do here? We have to access monitor REST somehow. First of all, it's exported. So what's the problem? The problem is that it uses what's called deep reflection, meaning it reflects over details in here. So exporting alone doesn't do. We have to also open the package for reflective access. Oh, there must be a compile. There was an interesting Stack Overflow question about opening modules and exporting them. And the reason was, let's do this. Now it works again. The question was, it's possible to say the open module here. You can just say this is an open module, so it opens every package. Great. But what I cannot do, I cannot say something like export it here. Why can I not say export it? Why can I open the whole package, the whole module, but why can I not simply export the whole module? The reason, and this is the difference between how you see exports and how you see opens. They might seem like very similar, and just an open is basically just an export with, you can see even more stuff. But that's not the way you should look at it. By exporting a module, you're defining an API that other modules are going to depend on. You can use open packages to reflectively gain access to APIs, And so when you have an open module, other modules can indeed start depending on your internals by reflecting over them. But that's usually seen as a hack to use reflection for. Reflection's bigger use case is that you have someone reflect over your code to provide a service to you. In this case, it's XML serialization. It could be Hibernate doing persistence, or it could be Spring, or what's other big use case? I forgot it. I've written somewhere. So anyway, so there are a bunch of use cases where someone provides a service to you. But this service provider does not depend on your code, right? So even if you open the entire module, it doesn't matter. It won't depend on this one package that you have. So exports define an API. Open just say, you can use this if you want. So if you have an open module, that would mean from one module release to the next, your whole set of packages could change, and everybody reflecting over specific packages would break. Another problem, because nobody's really likely to reflect over specific packages. As I said, most likely JuxB is just going to look at the packages that you annotate properly, and when they change, nothing breaks. Same is not true for exports. If you export the entire packet, the entire module like this, if that would work, and you rename a single package, then you basically broke your API, and you're not supposed to do that. So there's no blanket exports. There's also no wildcard exports. This doesn't work either. You have to specifically put in the packages that you want to export. Good. Yeah, I think actually that was the big step of the migration. We could now, of course, go on, and I think it's just persistence and main that's missing at this point. And if we did that, we would see that the whole thing's clean up, that modules that I had to add, that they go away. And we could do that. We could have a small look into services. We could try to make main more self-sufficient by adding its main class to it. But looking at the clock, I think this was the stuff that I definitely wanted to cover. And the rest I'll leave open for individual requests, so to say. Let's see.
Yeah, that was absolutely awesome. I mean, I think this is one of the kind of sessions that everyone really wants, because it's it's very much a practical, hands-on kind of session. And normally at conferences and user groups, we tend to get more of the introduction and the kind of how-tos, but never really something hands-on like this.
Yeah, it's as I said earlier, it's kind of like if you know too little about the module system, then this like every new technology, right? Then this might seem chaotic. It's always hard to capture on the one hand the real life issues, and on the other hand, to not kind of like make it seem more complex than it actually is. So I can guarantee you that what I just did with a little reading, it's really not that tough to make the individual decisions. It's just like you have to know what's going on in the rest. But yeah, so this is kind of like valuable, I think, in that sense, that you can see what you have to know to start working on this, and it's not that much. Read a little bit, and you're ready to do it on your own project. I want to add some. You can, as I said, you can see the slides online. I already mentioned that I wrote a migration guide, which covers these and more things in detail. It doesn't do the modularization, just does the migration to Java. If you run into specific problems, I set up a small page where you can commit pull requests, so we can gather funny little things that break on Java 9. And most importantly, if you want to know the basics or the details for these features or others, which, as I said earlier, you can get in early access already, which looks like this, by the way. Yeah, so with that, I'm done. Thank you.
Awesome, and there's a 37% off code there for anyone who's interested in getting that as well. FCC Parlog. So, well, I'm just asking if there's any final questions in IRC. Nothing in yet, but it just leaves me to say a massive thank you for your session. Let me just quickly, I want to share my screen now. Just want to show you something that's coming up very soon. There we go. So that was the session that we just saw. Please do follow Nicolai on Twitter at NIPAFX, NIPAFX. And the next session that we've got is very soon, August 9th. We have two. In fact, everyone's been amazingly treated here. We've had we've had Simon Ritter on, now we have Nicolai on, and now we have Matt Rabel and Josh Long next. So what a great lineup we've had recently. Building robust APIs and apps with Spring Boot and Angular with Matt Rabel and Josh Long. So that's coming up on the 9th of August. Please RSVP if you haven't already to the meetup page. And let me just check if we have any questions. So no live questions, but thanks a lot. And everyone's loving it. Big thumbs up. Thanks a lot. This session's one for the books, and we'll definitely share this so that people who really want to see rather than hear how to migrate, this is a great guide. Thank you very much, Nicolai. It's a pleasure.
Sure. Thank you too.
And I would just like to say a big congratulations to Nicolai as well, who actually was one of the V juggernauts of 2016, which is one of the top 5 sessions in the year of our virtual jug session. So big congratulations to Nicolai as well.
Thank you. I want to split that at least 50-50 with the JNet 5 team though, because they wrote the stuff that I talk about. It's just
oh no, come on, you need to take all the credit. That's how it works in this game.
Basically, I basically just come up with the whole thing. I just, they just type down the code. It's just
they're just cycling the pedal, but you're doing the pedals underneath. It's you on top.
Exactly.
Awesome. Massive thank you to Nicolai. Thank you everyone for attending. And any further questions, please contact Nicolai online. And also, we'll share the links, including the code samples on the GitHub account. And till next time, thank you very much. See you later, everyone.
Bye.